So this is the last part in this series of 3 videos going over this final exam review for the MCT4C course. And the last one we did, I took a look at the part 2 questions 1 to 9, so we're going to start at 10 here and finish off the rest of the exam. And so in number 10 here on page 9 it says expand and simplify, and we're asked to expand this monomial negative 3xy into this binomial. And so the expand part, we would start multiplying. So we would go and multiply the negative 3xy by the 4x squared y. And so we multiply negative 3 by 4, which gives you negative 12. And we multiply x by x squared. Now, don't forget that if you don't see the exponent, there's a 1 here automatically. So it means there's 1x here, and the x squared means there's 2 x's there multiplied. Not 2 x's added, 2 x's multiplied. That's what x squared means. And so when you multiply an x by an x squared, you add the exponents, because it really means there's 1 here and there's 2 more here, so altogether there's 3 of them multiplied. So that's why the product would be x cubed. And similar with the y, we have y here, which is a y to the first, and a y here, which is another y to the first. So altogether there's 2 y's multiplied, and so that's what y squared means. You add the exponents. 1 plus 1 is 2. So next, we would I multiply the negative 3xy by the first term. Now I multiply the negative 3xy by the second term. And so negative 3 times 5 is negative 15. X times x would be x squared. And y times y cubed would be y to the fourth. Now there's no simplifying here because those are unlike terms, and so we cannot make it any simpler. There will be some simplifying in the second one here. So for b here, we would start by multiplying the x by x to the fourth. And so x to the first times x to the fourth would be x to the fifth, adding the exponents. 1 and 4 add to 5. Next we would multiply the x by negative 5x squared. And so x, now there's really a 1 here in front. 1 times negative 5 is negative 5. And then adding the exponent 1 here and 2 here, you get 3. So x times x squared is x cubed. So it's negative 5x cubed. Next, we multiply the x by this x, which is x squared. And then x times the negative 6 would be negative 6x. So I've multiplied the x by all 4 terms here, and that's these first 4 terms here. Now I would turn my attention to the next term in the binomial at the beginning here, the 3, and multiply by each of these, and that would be the last 4 terms. So 3 times x to the fourth is 3x to the fourth. 3 times negative 5x squared would be negative 15x squared. 3 times x is called 3x, and 3 times negative 6 is negative 18. And now the simplifying part is when we identify like terms, not necessarily pairs, it could be more than 2, and combine them together. Now there's only one x to the fifth term, so we write that down, and there's only one x to the fourth term, so we write the 3x to the fourth. And it's a normal convention to write it from highest power of x, or whatever the variable is, to lowest. So that's why we normally write it that way. It's just a convention. It's a way things are normally done. Next, after the x to the fourth term, there is only one x cubed term, so we write that next. And then we start getting into some like terms. There's an x squared here and a negative 15x squared here. Now remember, there's no number in front, so it's automatically 1. So we have 1x squared minus 15x squared. 1 take away 15 is negative 14, so it would be negative 14x squareds. Remember, when you subtract like terms, what you end up with is the same kind of term. Okay, so think of it as like if we had, $1, and we're going to subtract 15 from that. You can actually go in the negatives of money. It just means you owe. It's still minus $14. It's not something different. Okay, so same kind of term. As well, we've got a negative 6x and a 3x. Negative 6 and 3 add to negative 3, so negative 3x is the combined term there. And there's only one number in the end, one constant, so we write minus 18 on the very end. For question number 11, we're told that John owns a mechanic business. He operates out of his home garage. He charges an hourly rate of $60 per hour, and there's a fixed fee of $35. So we're asked to create an equation that models the cost of repair to the amount of time it takes John to fix the vehicle. So I'm going to call C of H. C is the cost for H hours of work. So C of H is the cost, H is the number of hours that he actually works on it. So his cost is a function of time. We often read it like that. Is 60 times the number of hours, because he gets $60 for every one of the hours he works, plus the $35. So 60h plus 35. Now, if you want to use a different variable, if you want to use t, you could write it as something cost equals 60t plus 35, and that's fine. In question B, you're asked, what amount of time did John take to repair a truck if the before-tax bill was $305? So basically, that's the cost. So we're going to put 305 here. So we're setting the 60h plus 35 equal to 305. Now, if you want to write the 305 over here, that's okay. Nothing wrong with that. And so I want to solve for the time here. I want to solve for h. So I would subtract 35 from both sides, or some people say bring the 35 over and subtract it from the 305. In any case, we're taking 305 and taking 35 away, which is 270. And I want to solve for h here, so I need to get rid of the 60. So I would take this line, which is exactly what's written there, and divide both sides by 60. So that this 60 would divide out, and what we're left with then is just h on the left here equals 270 over 60 divided by 60, which is 4.5. So the repair took him 4.5 hours. Question number 12 is the first of some of the trigonometry, and you're asked to find the indicated unknown sides. You're asked to find how long the side is right here. So the first thing I would do here is identify what the side is that I know in terms of opposite, hypotenuse, or adjacent, and the side I want to find. So in terms of this 28-degree angle, the x is a side right beside it, and it's not the hypotenuse. This would be the hypotenuse across the right angle. So we would call this side the adjacent side. The 3.6 is straight across from the 28, so this would be called the opposite side. And if you remember the SOHCAHTOA acronym, opposite and adjacent is tan, T-O-A in the end, so tan is opposite over adjacent. So that's why I would write the tan of 28 degrees equals 3.6 over x, because the 3.6 is the opposite side. That's why it must be on top, and the x is in the denominator because the a is last, the adjacent side is last. Now I want to solve for x here. Right now the x is in the denominator. So I want to do a little bit of algebra here, algebraic manipulation to get the x alone. So what I could do, and there's different ways to do this, is I could multiply both sides by x. And then what would happen is those would divide out, and we're just left with the 3.6 on the right here, and so we have it equals x tan 28. Now I'm trying to isolate for x. So x is multiplied by the tan 28 right now. So what I would do is I would take that same line, that's what's written right here, and I would divide both sides by the tan 28, so I get the x alone. And so these tan 28s divide out, and then we are left with just x on the left, and it would equal, and this is the calculation right here to find what x is. And so we would bring our scientific calculator over and go 3.6 divided by the tan of 28 degrees. And so I get 6.77, so I'm going to round to 1 decimal place and make it 6.8. Now, if your calculator, you don't have a graphing calculator, one that can type it in basically the same as you would write it, you actually have to evaluate the tan of 28 before you can divide it into 3.6. So you might go tan of 28 and get that decimal. It's about 0.5317. And then you have to go 3.6 divided by that decimal. And keep several decimal places. So there's the 6.77 again. So flipping over to the next page on question number 13. And so in question number 13, we're asked to find angle B, this angle up here. So in terms of this angle, the 20.5, and again, I would label the sides that I'm working with so I can know what trig ratio to use. So this would be the adjacent side, because it's right beside angle B. And although this is also beside angle B, the AB side, this is the hypotenuse because it's right across from the right angle. So the trig ratio that involves adjacent and hypotenuse is the cosine in the middle here. Cosine is adjacent over hypotenuse. So I would write cos B equals 20.5, the adjacent over the hypotenuse. And then I would divide that 20.5 by 30.8 and get 0.6656. And then we would take the inverse cosine of that, or arc cosine. So second and then 0.6656 and it gives me 48.27, so it's about 48 degrees. Let's bring our SOHCAHTOA down here again for 14. So in 14, we're told we have this 200-meter tall communication tower, and it has two guy wires attached to support it. So the longer one makes an angle of 38 degrees with the ground, and a shorter one makes an angle of 48 degrees with the ground. And we're asked to determine the difference in length. In other words, how much longer is this one than this one, or how much shorter, I guess, is this one than this one. Just the difference in the length. Now, we're assuming that the communication tower is built vertically, so it's straight up and down. That would have to be a right angle. So we're working with two right angle triangles here. And then the two triangles, I've called the lengths L1 and L2. And so I'm going to deal with the entire big right triangle first, because I'm working with a 38-degree angle. And so in that triangle, straight across from the 38 would be the 200. So we would call this the opposite side. And then the L1 is across from the right angle up here, so this is the hypotenuse. So the trig ratio involves opposite and hypotenuse is sine, so that's why I'm using sine here. So I would write sine 38 equals 200 over L1, opposite over hypotenuse, and I want to solve for L1. So I would first multiply both sides by L1, so that those divide out, and I'm left with 200 on the right equals L1 sine 38. Now I want to rearrange and get the L1 alone, so I would take this line, which is exactly what's written here, and divide out the sine of 38. And so these sines of 38s divide out, and so L1 is equal to 200 over the sine of divided by the sine of 38. And so we will go 200 divide sine 38. Oh, that's 20. I need 200 here. So 324.85, so I'm rounding to the nearest meter, is the 325. Again, if you don't have a calculator that will divide like this, what you can do is find the sine of 38. It's that decimal, and then go 200 divided by 0.61, and keep several decimal places. And so there's the 324.85, which rounds to 325 again. For the second one, dealing with now this smaller right angle triangle, the 200 is still the opposite. The L2 is still the opposite side. So we're still working with sine. Very similar calculation. Sine 48 in this case would equal 200 over L2. Multiply both sides by L2, so that it looks like L2 sine 48 equals 200. And then divide out the sine of 48, just like we divided the sine of 38 out here. And so that's the calculation. And so very similar to before, we would divide 200 by the sine of 48 to get about 269. And then of course the difference in length, we would go the 325 minus 269. And so 56 is the difference in length between the two cables, the two guy wires. On to question number 15. We're asked to find side B, which would be this side right here across from angle B. And this is not a right triangle, so we're starting into some of the sine law and cos law stuff here. Now, the first thing you should do, because you can probably see that this is sine law, you have to determine, what do I need to be able, what can I use here? Is it going to be sine law or is it going to be cos law? Well, in order to find a side, and actually here's a cosine law written down here. In order to find a side using the cosine law, what you need to know is the other two sides and the angle between them. And that's not the information I have here. I don't know this side up here, the A side. I do know the C side, and I do know the angle across from B. In order to get sine law working for you, what you need to know is what I call an angle side pair, where you know both the angle and the side across. Okay, so as soon as I see that, I start thinking sine law. And then if I want to find a particular side, I also need to know the angle across from it. You see, sine law looks like this. It's sine of, well, this is actually angle B. There's actually a B there. And the 81 is actually the angle C, and this is side C down here. So in order to use the sine law to find something, you basically need to know 3 of these 4 things. That's why you need to know an angle-side pair, and if I'm finding a side, I need to know the angle across. If I was trying to find this angle B here, then I'd have to know side B. Okay, let's just get rid of those couple of writings there so it doesn't interfere. So that's why we're using the sine law here. So it would be the sine of 36 over B is equal to the sine of 81 over 8.4. Now, I want to rearrange and get the B alone. So we would take this B here and multiply by the sine 81. A lot of people call this cross multiplying. So B sine 81 is equal to 8.4 times the sine of 36. Now I want to isolate for B, so I divide out the sine of 81 to get the B isolated beside itself. So this line is the same as this line, so I'm going to divide out the sine of 81. And so there's the calculation there. So we would go 8.4 times the sine of 36, close bracket, and then divided by the sine of 81. And it's pretty close to 4.9989, so I'm rounding to 5 meters here for my length. Now again, if you don't have a calculator that works like this, you'd actually have to find the decimal equivalent to the sine of 36 and the sine of 81. And so we could actually go sine 36, find what decimal is, the sine of 81. You need to do both of those. So basically it's 8.4 times the sine of 36, so times this decimal. So we go times 0.5877, and yeah, again, keep several decimal places, and then divide by the sine of 81. So we need to divide by this 0.987688 number. And we get our 5 again. So that's number 15. On to number 16, we're asked to solve this triangle. And solve a triangle means to find all unknown sides and angles. And so we're given originally here these 2 sides. We know side E and side F and angle D. So we need to find the other 2 other angles and 1 other side. And so I'm going to find side D first. So this is angle D down here, so this would be side D up here. And so this is a cosine law situation because you know 2 sides and the angle between them. And so we can use the cosine law to find that opposite side, the third side. So D squared would equal 8.6 squared plus 11.2 squared minus 2 times the product of those 2 sides times the cos of 58, the angle across from D, which is called angle D. And so in the calculator, we would actually type in 8.6 squared. And if you want to do it piece by piece, that's the 73.96. 11.2 squared is the 125.44. Now, you have to evaluate all of this before you subtract. So I would have to go and multiply 2 by the 8.6. And I forgot multiplication here. Insert a multiplication there. Times the 11.2. I don't actually need to put a times there, but I will just because I did it for all the other ones. Times the cos of 58. So that's that 102.8. Now, if your calculator doesn't work quite the same as this one, make sure you find the cos of 58 and then multiply it by 11.2 and 8.6 and 2. And so then we would go just 73.96 plus this minus this, get 97.28. That's what D squared equals, and then we'd take the square root of that to get side D is about 9.9 kilometers. So this side is 9.9. Now we know all the sides. We need to find either angle E or angle F next. It really doesn't matter which. And I'm going to use the sine law here to find angle E, although I could have used the cosine law. That would have worked as well. Because once you start knowing more about the triangle, you get more options about what you can do. So the sine of angle E over 11.2 would equal the sine of 58 over the side I just found, the 9.9. So next I'm going to cross multiply. Sine E times the 9.9, which is what's on the left here, would equal 11.2 times the sine of 58, which is here. And I'm trying to isolate the sine of E, so I'll divide the 9.9 out. So these divide out, and we get sine E on the left here is equal to this. So in the calculator, you'd need to go 11.2 times the sine of the 58 and divided by the 9.9. And so that works out to be about 0.9594, and then we would take the arc sine or inverse sine of that to get the angle. So we go inverse sine 0.9594, and it works out to be about 74 degrees rounded. Now once I know that this is 74, I could find angle F by subtracting 74 and 58 from 180, and so angle F is 48 degrees. And so on to the next. Turning over to page 12, and question 17 is the first of a couple questions on the trigonometric functions. And in 17, you're asked to state the amplitude, period, phase shift, and vertical translations for each of the four of these. The first one in A is a graph. So we notice that the middle axis right through the middle of the graph is actually on the x-axis. And so the amplitude is the distance from that to a maximum point, which is 4 units, or the distance from that to the minimum point, which is still 4 units. Even though you're going down, you would not say it's negative. The amplitude is always a positive value. It's 4. Period is the length of one cycle. So for example, if we start at a maximum here and trace along the graph, we get to the next maximum here, which is at 120 degrees. And so that's the length of the period. You don't have to go from maximum to maximum. If you want to go, for example, let's say from where it crosses the x-axis to where it finishes that cycle, from 90 to 210 is still 120 degrees. Next, the phase shift depends on whether you're talking about cos or sine. The cosine starts on a maximum point, at a high point, and so if you're talking about the cosine, there actually would not be a phase shift. For the sine function, though, the sine function normally starts at the origin and goes up if it's not translated or transformed at all. So if you find a point like that, which would be right here at 90, you start going up and there's one full cycle for sine. So the phase shift would be 90 degrees to the right if you're talking about the sine function. And since the middle axis through the middle of the graph is on the x-axis, there is no vertical translation at all. For the second one, if you don't see a number in front of the sine or cos, then the amplitude is automatically 1. And so the amplitude's 1, the coefficient in front of the x is a 1 again, so the period is the standard 360, or 360 divided by the 1 in front of the x is still 360. The phase shift is 90 degrees to the right. It's always x minus what the phase shift is, so it's x minus positive 90, so it's 90 to the right. We'll talk about the opposite when we get down here to C. And there's no number added or subtracted on the end, so the vertical translation is none. There is no vertical translation. For C, y equals negative 5 sine 2 in brackets x plus 25. The negative 5 tells us that the amplitude is 5. Again, even though that's negative, the amplitude is still 5 because it's just a distance. The negative, if you were graphing this, would mean that it's reflected upside down or reflected in the x-axis compared to the 5 sine graph. The period would be 360 divided by this 2, which is 180. The phase shift is 25 left. In order to write this the same as the previous one, I could write the x plus 25 as x take away negative 25, and it's always x minus what the phase shift is. So this is the negative 25 would mean that you're going left. The negative means you're going left, and the 25 means you're going 25 degrees. The vertical translation, because there is no number added or subtracted in the end, would be none. For D, 4 is the amplitude. to get the period, we would divide the 1/3 in here into the 360, the standard 360. Now, 360 divided by 1 is the same as 360 times the reciprocal of a third. All right, I think I said 360 divided by 1. 360 divided by 1/3 is 360 times 3 over 1. I didn't write the 1 on the bottom here, but that means the same thing. And so 360 times 3 is 1080. There is no brackets in here with something added or subtracted to x, so there is no phase shift, and the 5 plus 5 in the end means the vertical translation is 5 up. For question number 18, we're asked to graph each of the following on the grid at the right. And so the first one, y equals 2 cos x plus 45 minus 1. The amplitude would be 2. So for when you're graphing, find these 4 characteristics and then use that from the basic cos or sine to graph the function. Because there's no coefficient, or the coefficient in front of x is 1, the period would be the standard 360. The phase shift would be 45 left. Remember, similar to this, and this was 25 left, so this would be 45 left. And the minus 1 means it's moved 1 down. Now, when I'm graphing the trig functions, I always handle the vertical translation first. And so that's this red dotted line here. The scale I'm using is each block vertically is 1, so that's 1, 2, 3, 4. This would be 5 right here. So it's kind of like that 1 down. That red dotted line is, you kind of treat it as though that's the x-axis. So everything's in reference to that. So this is a cosine function. A cosine function, and the amplitudes too, would normally start 2 units above the this on the y-axis. Now, the phase shift is 45 left, so the start of this period at this maximum is going to be 45 units to the left. If you look at this scale on the horizontal axis, every block's 30, so that's 30, that would be 60, that would be 90. So this is 30 left, that would be 60 left. So right in the middle between 30 and 60 would be 45. So that's why it's a block and a half left. The period is 360, so the end will not be at 360, it'll be 45 before that, or move to the left, or a block and a half left from 360. A 180 is normally in the middle between 0 and 360, so a block and a half left from that, which would be right here. We're 2 units below the middle axis, because the amplitude's 2. And then it crosses that red dotted line halfway between here and here, which would be at this point. A really convenient way to get those points, if you take a ruler and lay it so that it goes through by this and this, then that ruler would actually intersect that line right there. Don't draw the line, just to find that point. And if you lay a ruler right here, kind of like I'm doing this. And so notice that that crosses that axis right there. So that's a very convenient way to get those other points. Once you have those 5 points, then you draw your sinusoidal shape. And that's what y equals 2 cos x plus 45 minus 1 would look like. For the second one, y equals negative 3 sine a half x minus 30 plus 2, the amplitude would be 3. Remember, this negative means that it's flipped upside down compared to the 3 cos graph, or 3 sine graph, sorry. The period, we would divide the half into 360, so 360 divided by a half is the same as 360 times 2, which would be 720, fairly long period. The x minus 30 means it's moved 30 to the right, and the 2 means it's moved 2 up. So here's my vertical translation 2 up, this dotted line here. And it's a sine function, so it would normally start right on this if we start a period, a cycle. And the phase shift is 30 to the right, so instead of if there was no phase shift, I'd start right here, but I'll move 30 to the right. So my end would be 30 past the 720, so 1 block past that. Halfway between 0 and 720 would be 360, so the middle point is again 1 block, because they're all moved 30 to the right of that. Now, halfway between here and here would be this point. Now, if you want to count blocks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's 12 blocks from the beginning to the middle. So if you go over 6, 1, 2, 3, 4, 5, 6, and then 3 units below that, because the amplitude's 3, there's a minimum point. So same 6 blocks after this, there'd be a maximum point right there, and then you can draw your sine shape around that. So that's what it would look like. On page 13, question 19, it says use the graph at the right to answer each of the following. And the first one says, what's the distance from A to B? So we would count all these individual distances. So this is 2 plus 4, that's the 4 up, plus 6 to the right, that's that 6 there, and then plus another 4 plus another 2 adds up to 18. So to actually walk along this path to go from A to B would be 18 units, whatever the units are. To calculate the displacement from A to B, we want to draw right triangles around A and B, and so it would look something like this. And another side right here. And this is supposed to be a right triangle, so there would be a right angle right there. Now if you count along this bottom side from 2 to 8, that's 6. And then this is a y-coordinate of 1. You can actually count up to 9. That side will be 8. And so the sides are 6 here and 8 there. And so we can use Pythagoras' theorem. So the square root of 6 squared plus 8 squared, 6 squared is 36, 8 squared is 64. They add to 100, so the root of 100 is 10. So the direct distance from A to B, the displacement, would be 10 units. To find the displacement's a vector, so to find its direction, now this is the angle I'm using right here. And that would be the opposite side, that would be the adjacent, so that's why I'm using tan. So tan would equal 8 over 6. 8 divided by 6 is 1.3 repeating. And so we take the inverse tan of that. And the calculation would look like this. Inverse tan of 1.3333, put a few 3's there. And you get about 53 degrees. So this displacement vector, this angle would be 53. So if we go towards the east but 53 degrees toward the north, so east 53 degrees north, that would be the direction for that. And to draw the vector, that's this red vector right here. The components of vector AB, 6 is the x component, 8 is the y component. So the components would be 6, 8. For question number 20, a hiker starts right here, walks 25 due west, and then turns and walks another 4 kilometers. Now this line would be north, and we're going 50 degrees toward the west. So that's this angle in here is 50 degrees. And you're asked to calculate the magnitude and direction of the resultant vector. So we want its length and we want a direction. Now I can use the cosine law to find this resultant vector, but I need the whole angle in here. So this angle right here would be 90, because north is perpendicular with east-west. And this is 50, so if we add 50 and the 90 here, you get 140. So that's what the 140 represents, the entire angle between this vector and the 4 kilometer vector. And so I can use the cosine law. So it would be the square root of 2.5 squared plus 4 squared minus 2 times 2.5 times 4 times the cos of 140. Now, be very careful with this cosine here, because the cosine of 140 is negative. So we square the 2.5, we get 6.25, 4 squared 16, and then if you go 2 times 2.5 times 4, that's 20. The cos of 140 is negative 0.766 approximately. So when you multiply that by the negative 20, this would be a plus here. I've added the 6.25 and the 16 to get 22.25. And so this would be plus 15.32 from this. Add those, take the square root, and the length of that vector is about 6.1. So that's the actual, if somebody walked the straight line distance, 6.1 kilometers along there. To get its direction, it's kind of like, if you were to tell somebody to walk straight along there, what direction would you tell them to go? So we need to find this angle here. And so that's across from the 4, so I would write sine theta over 4, I'm using the sine law here, would equal the sine of the 140 over this side right here that we just found is 6.1. And so I want to isolate for sine theta, so I could multiply both sides by 4 here. So these 4's divide out, and on the left I now have sine theta by itself. And so on the right here, it's just 4 multiplied by the sine of 140. I would normally write the 4 in front here, so somebody doesn't think you have to multiply the 4 by the 140 and then take the sine of that number, because that's not what you're doing. So in my calculator, I would go 4 times the sine of 140, If you're using the graphing calculator, you don't actually need to put that multiplication in. And divided by the 6.1. So that's 0.4215, and so then we take the inverse sine of 0.4215. And that tells me the angle is about 25 degrees. So I'm going to round to the nearest degree. So that angle is, you go west, but not completely west. You go toward the north 25 degrees. So we would say that's west 25 degrees north. For question number 21, it says, explain why a round sewer cover is a much better design than a square one. And one of the reasons they're round is because a round cover won't, and there are other reasons too, but a round cover can't fall in the hole like a square cover could. A square or a rectangular one, if you actually physically turned it the right way, it actually could fall in the hole. But a round one is the same distance across everywhere, so it can't fall in the hole. So that's one of the reasons why a round sewer cover is a better design than a square one. And on to the last question, 22 here. You're helping a friend lay hardwood flooring in rooms that measure 15 by 12, 10 by 11, and 8 by 9. You're asked, what is the total area of all three rooms put together? So area of a rectangle is length times width. So we would multiply 15 by 12 and add to that 10 by 11 and add to that the 8 by 9 room. So 15 times 12 is 180, 10 by 11 is 110, and 8 times 9 is 72. And then we would add the three of those and get 362 square feet. So that's how much hardwood flooring that you have to cover, 362 square feet. And you're told each package contains enough flooring to cover 40. So then how many packages do you have to purchase to floor all three of the rooms? So since each one covers 40, we would take this 362 and divide it by 40. Now it gives us 9.05. So 9 wouldn't quite be enough. And you often will get some wastage as well. You'll cut one wrong or something like that, or you'll cut the end off 3 inches and you don't need the 3 inches, but it's wastage really. So it's good to round up, even though that rounds to 9, to round up to 10 or perhaps even 11. But if you round up to 10, then that's probably about 10% wastage, so that's not too bad. And that's the end of the video.